In this session, we first talk about the what is sorting, what is the main idea behind parallel sorting. So let's have a look on it. Table of content, the topic which we'll be discuss in this session. Sorting, what is sorting? Parallel sorting, design methodology, comparators, parallel merging network, the zero principle, improve sorting network, and example. Let's start with this sorting. First of all, what is the sorting? Sorting is the process of arranging elements in a group in a particular order, that is ascending order, descending order, maybe alphabetical order. So suppose there is an array which has a 10 element like 5 9 1 0 2 4 so on. We can arrange them in either ascending order or a descending order. Ascending order is a non-decreasing order and descending order is a decreasing order. You can see in the slide like ascending order is minus 1 0 0 1, descending order is a 9 7 5 5. There are many sorting algorithm like a bubble sort, selection sort, insertion sort, quick sort, merge sort. We can sort any we can use any of this algorithm to sort our array, but our main idea is parallel sorting to improve the time and space complexity of existing algorithm. That's why we define a parallel sorting. Parallel sorting is also known as a concurrent sorting. Means it's the parallel sorting algorithm running simultaneously, like running two tasks parallelly. This approach is opposed to traditional approach. Existing traditional approach is a sequential approach in which we sort element one by one in an array, but this algorithm sort two pieces of array simultaneously, means parallelly. That's why it is totally opposed to the traditional approach. Parallel algorithm is execute a piece at a time on a many different processing device and then combine together again at the end of the correct result. Means the parallel sorting algorithm first divide the input and process it, means arrange it in either ascending or descending order, and again combine the result and give us the output. Example of parallel sortings are parallel bubble sort, parallel merge sort. Design methodology. What is the design methodology? Parallel sorting mainly based on a comparator and divide and conquer methodology. Comparator is the base of a parallel sorting. Like we can use a comparator in a parallel sorting. There are a big network of comparator and parallel merging. For the improvement purpose, we divide our input for a network of comparator and put along with a merging network too. Implement and divide and conquer methodology and achieve the parallelism. The methodology is very effective for a time complexity. Like in parallel sorting, we divide our input and give to the network of comparator. Comparator sort them in either ascending or descending order, and then merging network will merge that element and give us the output. That is whole process is divide and conquer methodology. It is very effective for a time. So first of all, we gain the basic idea of what is comparator. Comparator can be defined as an element which take a two input and give us the output based on a comparison of input. Like you can see in the slide, x1 and x2 are a two input which is given to the comparator, which give us a two output, y1 and y2. In y1 we store the minimum of between x1 and x2, and in y2 we store a maximum of x1 and x2. Means you can see it is in a sorting order, like a minimum is the above and maximum is the bottom, like they are two sorted elements. So this is the main idea behind the comparator. More generally, in real life we have not exactly two element, but we have more than two element. Like we can say suppose we have a vector like x1 x2 up to xn. and we have to arrange them in a either we have to sort them. So it gives us the output like y1 y2 y2 y1 y2 up to yn. So it is a permutation of one of the permutation which for which we can say that y1 is less than y2 up to yn, which is a ascending order. So one way to build a progressive bigger network is like design Sn plus 1. Sn is the network of a comparator. So if we have to make a network for n plus 1 element, which is a Sn plus 1, then we can make that network from the Sn. So Sn is a full network which can be formed by several comparators according to the comparator. You can see in this picture we can represent Sn network like a rectangular box and Sn. You can see in this slide there are two scenarios. First is the input side, second is the output side. There are at least two obvious way to do this, illustrated in both network have n plus 1 input and n plus 1 output. The network on the left corresponded to sorting by selection. The largest element fall to the bottom, and then we use S to sort the n remaining. Means there are total n plus 1 element. First we will choose the largest element and put at the bottom, and again we apply the same process to remaining n element, and then again we put the largest to bottom, and this way we can sort the whole array in either ascending or either ascending order. Or if you have to sort the array in descending order, then we put the smallest element at the bottom. So this is the arrangement of a comparator. This is the like a stepwise. It is a network of S5 obtained whether we use a selection or insertion. There are two useful measures of quality for our network. Like first we can simply count the number of comparator needed to build Sn. This is called the size of network. In the above example, S5 contains 10 comparator, and it is equivalent that in a generally Sn will contain n into n minus 1 by 2. Suppose we want to make a network for n element, then we require n into n minus 1 by 2 comparator for same. The second measure of interest is at time the network stack. Like above network is to optimize the time whatever the existing algorithm is take. So we assume that the comparator take a constant time to operate, but the course cannot fire because its inputs are ready. We define the depth of a network to be the maximum number of comparator through which the input must pass before arrives at output. So you can see in this picture the depth of our network is 1, 2, 3 or 4. For S5 network the depth is a 4. Parallel merging network. So when we divide our input and pass through the Sn, we also require to merge them to give us a final output. Suppose there is a n integer, so we can divide them. So 2n size of array can make a 2n output. So the comparator, so parallel merging networks we can represent like a Fn. This merging network will do the merging task, provide each of the two group of input is already sorted, then each input appear on the output and output are also sorted. You can see in this picture there are two Fn network, and they will merge the input and give us the output. So suppose there are two group there are two group, one is a w1 w up to wn, and the second group is a x1 x2 xn up to xn, and the output is a y1 y2 to y2n because we have a two group of n size. So the basic idea of merging network, we merge the odd element, we take a odd position element from the first group and the second group, and in the second scenario we took a even position group from the even position element from the one group and the second group, and we pass them through the comparator and combine them to get our final result. Zero principle. To prove our sorting network work as they should, we use the following somewhat surprising propositional known as a zero principle. So zero principle very useful to prove our network is a effective or not, whether it is give a true result or not. Like the principle is a sorting network with an input correctly sort any set of value on its input if and only if the correctly sort all the to an input vector consistently. This is an improved sorting network. Like we have a 2SN network and we combine them and to give a FN network which will give us the output. This scenario is based on divide and conquer methodology. That's why it is a improving sorting network. This is what we have discussed. The complexity of this network is log square n, and for that we require a number of comparators is n log square n. So it is also called an odd even merging sorting network because we took odd and even position elements. And if we talk more about in this technique, like if algorithm have to sort an element, for making a comparison between must take at least log n factorial in the worst case. Thus the sorting networks for an element must include at least log n comparator. For example, suppose there is a sorting network which have 16 elements, but it must contain 45 comparators. The odd even sorting networks is if we can represent one S60 contains 63 comparator. The different network is also known that use of only 60 comparator, and this is the size is log n, and we can represent is n log n, which is our algorithm. So we talk about the example for our network. We in this slide we talk about the parallel merge sort. What is it, how parallel merge sort working? Like a parallel merge sort, first we give the array, it will divide them and perform the task, means sort this piece and give parallelly sort that pieces and give us the output, which is the form like a tree. This is the example of simple merge sort. Like we have given an array of 7 element, we divide it in 3 or 4 size, and again we divide into 2 and 1 element, and then we merge it in a ascending order. This also merge, and we then also combine and sort them in ascending order. This is a simple merge sort. The time complexity of this merge sort is n log n, but we now talk about the parallel merge sort. This is the whatever sub problem is created by a simple merge sort, we parallelize them, like maximum parallelization achieved by one processor per node. Perform merge sort on the following. If suppose we have to perform a merge sort in a following list 4 3 2 1, and we use the two processor P0 and P1. Like first P0 is a 4 3 2 1, and divide into 4 3 and 2 1. This two processor P0 and P1 running parallelly, so our task get easier. It is 4 3 divided into 4 3, it will combine in ascending order, it will also combine in ascending order P1, and then two results are combined and make a whole array, whole output. Here we took a two comparator means they running simultaneously, means parallelly, and sort this whole array. The time complexity of this algorithm is log n, which is very much less than the existing algorithm. Okay, thank you.